population proportion video. In a survey of N students, 600 said they owned a smartphone. A 95% confidence interval for the proportion of students owning a smartphone was given by these two values. If we add those two values together, we get the midpoint. Just doing on the calculator here, the midpoint here, P is 0.375. So 600 is 0.375. Get N now, because 600 over N is equal to P, which is 0.375. So 600 divided by 0.375 is equal to N, which gives 1600. Is that how many students were surveyed? If the margin of error for a 99 is given by this, construct a 99% confidence interval for the proportion of students owning a smartphone. Okay, well, we just fill our values in. It seems a little bit silly, but that's what we're asked to do here. 2.575. 2.575 by the square root of, when we do 3 over 8 is easier, by 5 over 8 divided by 1600, and that's going to give a value of 0.03116, so 0.0312. So we're adding 0.375, 03, well, I'll just add the 1, and we're going to get 6406 at the higher end, and 0.375 minus 0.031 is going to give 344 at the lower end. So we could finish by putting it in square brackets, or we could put the interval by, I think putting P like this is probably the easiest way, 0.406 and 0.344. And this is our 99%. So it's gotten wider, 34 to 40%, it's 6% wide. Our original one was only 4% wide. You can see 35 to 39 up here. Now, question 13, a 95% confidence interval is given by this. We've seen this already. Another method is this 1 over root n. Now the margin of error, basic margin of error, is equal to 1 over root n. A couple of basic examples. If n is 100, 1 over the square root of 100 is 1 over 10, 0.1, which is 10%. And in the political surveys, n is normally around 900 to 1020. 1 over the square root of 900 is 1 over 30, which around 3%. I'm just rounding off for just introductory purposes here for the other method to use 1 over root n instead of what we've been using so far. So part 1, we're asked construct a 95% confidence interval using both methods for a sample size of 400 with sample proportion 10. So they're telling us here P is equal to 0.1, 1 minus P is equal to 0.9, and if we use the method we've always been using, 1.96 by the square root of 0.1 by 0.9 divided by my sample size of 400, that's going to give me 0.0294. So that's going to be the spread away from the center. The second method, I'm going to get 1 over the square root of 400, which is 1 over 20, which is 0.05. So you can see here it's going to be a much bigger spread. For this one, it's going to be my P at 0.1 is what we're testing. I have to add on 0.05, so at the higher end 0.15 and at the lower end 0.05. And for the one up above, which I didn't do the interval for, our P is going to be, instead of 0.1 or 10, we're going to add 294 onto it, 0.1294. And if I take 294 away, I'm going to get 706 294 by 706, 0.0706. So you can see a much bigger spread here, 10% spread here. What have we got here? Just under a 6% spread here. What are we asked? Are we asked anything about it? Sample proportion a half. Now we're asked to do both. And we can just write them out. 1.96 by the square root of 0.5 by 0.5 by my sample size of 400 is the first one. And the second one is 1 over the square root of 400 again, which we know from previous is 0.05. So this P is going to be, we're testing 0.5. So we're adding 5 on, 0.55, and taking 5 away, 0.45. So again, a 10% spread. And for the top one, 0.049. So that interval, I'll just bring it down here. It's going to be 54.9, 54.9. And at the lower end, sorry, 0.549. And if I take that away, I'm going to get 451, 0.451. Just put my 0 in here. 0.549. 451. So they're getting closer here. You can see around 55 and 45. So comment on how the intervals are related. As the sample proportion increases towards a half, they definitely become closer. Method 1 and 2 become pretty much the same. And are they related intervals? How are the intervals are related as the sample proportion increases from a half towards 1? Well, there's symmetry in these curves, so as we go one way or another, the symmetry is going to stay the same. So as we move away from, or as we move towards the half coming in this direction, they'll get closer together. If we move away, going in either direction, they're going to get further apart. And which is the more useful of the two methods? You could do like the other side. If it's going to be 0.9 to 0.1 again, you're just reversing this guy around. The 0.9 to 0.1 change place. So I don't think you need to do the sum out again to just describe the symmetry of what's happening as it increases from a half towards 1. And method 1 is always more accurate. Method 2 is just an approximation. And method 2 really accurate, but method 1 is extremely accurate. Method 2 is kind of a handy one. The one I showed you at the beginning here, the only really reason we would use it is just a handy estimation of margin of error. And then question 14, we may as well do in this video as well. Companies often send junk mail to thousands of potential customers in the hope that some idiots will buy the product. The response rate is usually low. Suppose a company wants to test the response to a new product and sends a flyer to 1,000 people randomly selected from its mailing list of a massive 100,000 people. So the company get orders from 112 people. So let's have a look here. 112, my proportion out of 1,000 is equal to 0.112. So my 1 minus P is 0.888, is that right? 888. And 112 is 1,000. So we can create my confidence interval, 1.96 by the square root, 0.112 by 0.888 divided by 1,000. Going to give 0.195, and we were at 0.112, so we're adding quite a bit to it. So it's going to be, actually just going to bring us down into the negative here. So we're adding 112 to get 307. That's the higher end, and 0.195. We have to take away 0.195 from 0.112. And that's going to give negative 83. 0.0 0.83. So P between 0.307 and minus 0.083. And we asked to comment on this, explain what this interval means. Well, that's between 0% and 3% kind of. Well, I left an extra 0 out here. Just is that? No, that is. It's 0.3. It is 0.3. 19, 11, 30. Yeah. So between 0.3%. And what's that? Nearly 0.1%. I left out a 0. That's so annoying. This is equal to. Let me just go back over so I don't have to re-record a 10-minute video. If you manage to get through the boredom and get to the end, this is equal to 0.0195. So 0.112 plus 0.01. Well, we'll call it 0.020. It's going to get to me to 0.132 and 0.112 minus 0.02 is going to give me to 0.092. So my p-value is between 13.132, 13.2% and 0.092%. So the mailing company must decide whether to do a mass mailing. It won't be cost effective unless it produces at least a 5% return. I think we could suggest here that, here is a 10% return from 1,000 people, where the margin of error is about 3%. So a 10%, if we just look at the basic terms, 10% return is 100. We have 112. 1,000 is like that 900 that we started with, 3% margin of error. So a basic band here will be 7 to 13%. Will be more in line with this 9 to 13%. I don't know, I messed up on the last version of it, but this is the correct answer for question, is it 14?